Yes, there is actual verbiage in the NEC that would support the use of Schedule 80 PVC in lieu of GRC or IMC. NEC Section 300.5d addresses wiring methods subject to physical damage. Where subject to physical damage, conductors shall be protected by raceways, boxes, enclosures, or other approved means. Raceways, boxes, and enclosures shall be closely fitted to prevent the entrance of moisture and foreign object. Conductors entering boxes, enclosures, or raceways from different directions shall be protected from abrasion by suitable bushings, grommets, or equivalent. This section of the NEC requires that conductors that are subject to physical damage be protected by raceways, boxes, enclosures, or other approved means. Schedule 80 PVC, GRC, and IMC are all approved raceways that can be used to protect conductors from physical damage. However, it is important to note that Schedule 80 PVC is not specifically mentioned in the NEC as a suitable wiring method for use where conductors are subject to physical damage. Therefore, it is important to consult with a local building inspector or electrical contractor to ensure that Schedule 80 PVC is an acceptable wiring method for the specific application. Assuming that Schedule 80 PVC is an acceptable wiring method for the specific application, it would be required to meet the same cover requirements as GRC or IMC as listed in Section 300.5. Section 300.5e addresses covers for boxes and fittings. In outdoor wet locations where the authority having jurisdiction judges physical damage to be likely, covers of boxes and fittings shall be rainproof. Where condensation or splashing water is likely, suitable cover shall be used. This section of the NEC requires that boxes and fittings in outdoor wet locations be covered to prevent the entrance of moisture. The covers must be rainproof if the authority having jurisdiction judges physical damage to be likely. Suitable covers must be used where condensation or splashing water is likely. By meeting the same cover requirements as GRC or IMC, Schedule 80 PVC will be protected from the elements and will help to ensure the safety of the electrical system. It is crucial to understand how the National Electrical Code addresses the use of Schedule 80 PVC conduit as an alternative to galvanized rigid conduit or GRC and intermediate metal conduit or IMC, particularly in situations where wiring is susceptible to physical damage. Let's delve deeper into the specifics of the NEC and its implications for such applications. The primary reference point is NEC Section 300.5, which outlines the requirements for underground installations. Specifically, subsection D, titled Wiring Methods Subject to Physical Damage, is pertinent to this discussion. This subsection mandates that conductors exposed to physical damage must be safeguarded by raceways, boxes, enclosures, or other approved methods. The code emphasizes the necessity of close-fitting raceways, boxes, and enclosures to prevent moisture and foreign object ingress. Furthermore, it stipulates that conductors entering these enclosures or raceways from various directions should be shielded from abrasion through suitable bushings, grommets, or their equivalent. While Section 300.5d doesn't explicitly mention Schedule 80 PVC, GRC, or IMC, it establishes the general principle of protecting conductors from physical harm. It is worth emphasizing that Schedule 80 PVC, GRC, and IMC are recognized as approved raceways capable of providing this necessary protection. However, a crucial caveat exists: Schedule 80 PVC isn't explicitly identified within the NEC as a wiring method sanctioned for use in scenarios where conductors face physical damage. This absence of explicit endorsement necessitates careful consideration and consultation. Given this ambiguity, it becomes imperative to seek guidance from the local building inspector or a qualified electrical contractor. These professionals possess the expertise to assess the specific application and determine whether Schedule 80 PVC meets the applicable requirements and standards. The judgment is vital in ensuring compliance with the NEC and maintaining electrical safety. Assuming that Schedule 80 PVC is deemed acceptable for the intended application, it must adhere to the same cover requirements as GRC or IMC as stipulated in Section 300.5. This provision ensures consistent safety standards regardless of the chosen raceway material. To elaborate on cover requirements, let's turn to Section 300.5e, which addresses covers for boxes and fittings. This subsection focuses on outdoor wet locations where physical damage is probable, as determined by the authority having jurisdiction. In such instances, box and fitting covers must be rainproof to prevent water ingress. Furthermore, in areas prone to condensation or splashing water, suitable covers must be employed to protect against moisture-related issues. These cover requirements are essential for maintaining the integrity and longevity of the electrical system. By meeting the same cover specifications as GRC or INC, Schedule 80 PVC ensures adequate protection against environmental elements, including moisture and potential physical damage. This protection is crucial for upholding the safety and reliability of the electrical installation. In summary, while the NEC doesn't explicitly endorse Schedule 80 PVC for applications involving physical damage, it allows for its use under specific conditions. Compliance with Section 300.5, particularly subsections D and E, is paramount. Moreover, consulting with local authorities and qualified professionals is essential to ensure adherence to all applicable codes and standards. This collaborative approach guarantees the safe and effective implementation of Schedule 80 PVC as an alternative to GRC or IMC in appropriate settings. Now let's look at some additional considerations for using Schedule 80 PVC conduit. Firstly, understand the difference between Schedule 40 and Schedule 80 PVC. Schedule 80 PVC has a thicker wall than Schedule 40 PVC, providing greater resistance to physical damage and high temperature ratings. While Schedule 40 is suitable for many electrical applications, Schedule 80 is preferred in areas where the conduit is more likely to be exposed to impact or stress. Secondly, consider the specific installation environment. Factors such as exposure to sunlight, chemicals, and extreme temperatures can affect the performance and longevity of PVC conduit. If the conduit is exposed to direct sunlight, use PVC conduit that is UV resistant or paint it with a compatible paint to prevent degradation. Thirdly, ensure proper support and spacing. PVC conduit must be properly supported to prevent sagging or damage. Follow the NEC guidelines for support spacing, which varies depending on the size and type of conduit. Generally, smaller conduit sizes require more frequent supports. Fourthly, use appropriate fittings and connectors. When installing PVC conduit, use fittings and connectors that are specifically designed for PVC. These fittings are typically glued to the conduit using PVC cement, creating a watertight seal. Ensure that the fittings are properly sized for the conduit being used and that they are installed according to the manufacturer's instructions. Fifthly, pay attention to bending requirements. PVC conduit can be bent using a conduit bender, but it is important to follow the manufacturer's instructions to avoid kinking or damaging the conduit. Alternatively, pre-bent elbows and sweeps can be used to change direction without bending. Sixthly, consider expansion and contraction. PVC conduit expands and contracts with temperature changes, so it is important to allow for this movement in long runs. Expansion joints can be used to accommodate expansion and contraction, preventing stress on the conduit and fittings. Seventhly, ensure proper grounding. Although PVC conduit is non-conductive, it is important to ensure that the electrical system is properly grounded. Grounding conductors should be installed inside the conduit and connected to the appropriate grounding terminals of boxes and equipment. Eighthly, comply with local codes and regulations. Electrical codes and regulations vary depending on the location, so it is important to check with the local authorities to ensure that the installation complies with all applicable requirements. Ninthly, consider the application. Schedule 80 PVC is often used in direct burial applications, but it is essential to adhere to the burial depth requirements outlined in NEC Section 300.5. The depth depends on the voltage of the circuit and the location of the raceway. Tenthly, avoid using PVC conduit in hazardous locations. PVC conduit is not suitable for use in hazardous locations where flammable gases or vapors may be present. In these areas, use rigid metal conduit or other approved wiring methods. 11thly, be aware of derriting factors. When multiple conductors are installed in a single conduit, the ampacity of the conductors may need to be derrited according to NEC Table 310.15 cone. This diarting is necessary to prevent overheating of the conductors. 12thly, ensure proper labeling. Label the conduit with the appropriate voltage and circuit information to facilitate future maintenance and troubleshooting. 13thly, consider the use of pull boxes. In long conduit runs or where there are multiple bends, pull boxes may be required to facilitate the pulling of conductors. The spacing of pull boxes depends on the size of the conduit and the number of bends. 14thly, avoid overfilling the conduit. The NEC specifies the maximum allowable fill for conduit, which is the percentage of the conduit's cross-sectional area that can be occupied by conductors. Overfilling the conduit can make it difficult to pull conductors and can lead to overheating. 15thly, use appropriate tools. Use the right tools for cutting, bending, and installing PVC conduit. Using the wrong tools can damage the conduit and lead to unsafe installations. 16thly, inspect the installation. After completing the installation, inspect the conduit for any signs of damage or defects. Ensure that all fittings are properly secured and that the conduit is properly supported. 17thly, consider the long-term maintenance. PVC conduit is relatively maintenance-free, but it is important to periodically inspect it for any signs of damage or degradation. Repair any damage promptly to prevent further deterioration. 18thly, be aware of the limitations of PVC. PVC is a durable material, but it is not indestructible. It can be damaged by extreme temperatures, chemicals, and physical impact. Be aware of these limitations and take steps to protect the conduit from damage. 19thly, understand the grounding requirements for metal enclosures. When using PVC conduit to connect to metal enclosures, ensure that the enclosures are properly grounded. This can be accomplished by using a grounding bushing or by running a separate grounding conductor to the enclosure. 20thly, consider the use of expansion couplings. In long runs of PVC conduit, expansion couplings can be used to accommodate expansion and contraction due to temperature changes. These couplings allow the conduit to move without putting stress on the fittings or equipment. 21stly, ensure proper sealing. When installing PVC conduit in wet locations, ensure that all fittings and connections are properly sealed to prevent water from entering the conduit. This can be accomplished by using PVC cement or by using watertight fittings. 22ndly, be aware of the fire resistance of PVC. PVC is not a fire-resistant material, so it is important to consider the fire resistance of the overall installation. If fire resistance is required, use metal conduit or other approved fire-resistant materials. 23rdly, consider the use of cable ties. Cable ties can be used to secure conductors inside the conduit, preventing them from moving or becoming damaged. Use cable ties that are specifically designed for electrical applications. 24thly, ensure proper drainage. When installing PVC conduit in underground applications, ensure that the conduit is properly sloped to allow for drainage. This will prevent water from accumulating inside the conduit and causing damage. 25thly, consider the use of tracer wire. When installing PVC conduit underground, consider installing a tracer wire alongside the conduit. This will allow the conduit to be easily located in the future. 26thly, understand the requirements for direct burial. When burying PVC conduit directly in the earth, follow the NEC guidelines for burial depth and backfilling. The depth depends on the voltage of the circuit and the location of the raceway. 27thly, consider the use of concrete encasement. In some applications, PVC conduit may be encased in concrete to provide additional protection. Follow the NEC guidelines for concrete encasement. 28thly, be aware of the effects of chemicals. PVC can be damaged by certain chemicals, so it is important to check the compatibility of the conduit with any chemicals that may be present in the installation environment. 29thly, consider the weight of the conductors. When selecting PVC conduit, consider the weight of the conductors that will be installed inside the conduit. Ensure that the conduit is strong enough to support the weight of the conductors. 30thly, ensure proper ventilation. When installing PVC conduit in enclosed spaces, ensure that there is adequate ventilation to prevent the buildup of heat. 31stly, consider the use of seal-offs. In hazardous locations, seal-offs may be required to prevent the passage of flammable gases or vapors through the conduit system. 32ndly, be aware of the requirements for healthcare facilities. In healthcare facilities, additional requirements may apply to the installation of PVC conduit. Check with the local authorities for specific requirements. 33rdly, consider the use of flexible conduit. In some applications, flexible conduit may be used to connect to equipment or to navigate tight spaces. Follow the NEC guidelines for the use of flexible conduit. 34thly, ensure proper support for vertical runs. When installing PVC conduit vertically, ensure that it is properly supported to prevent it from sagging or buckling. 35thly, consider the use of expansion fittings for long vertical runs. In long vertical runs of PVC conduit, expansion fittings may be required to accommodate expansion and contraction due to temperature changes. 36thly, be aware of the requirements for swimming pools. In swimming pool areas, additional requirements may apply to the installation of PVC conduit. Check with the local authorities for specific requirements. 37thly, consider the use of non-metallic boxes. When using PVC conduit, non-metallic boxes are often used to provide a complete non-metallic wiring system. Ensure that the boxes are properly sized and installed. 38thly, ensure proper bonding of metal components. When using PVC conduit in conjunction with metal components, ensure that the metal components are properly bonded to the grounding system. 39thly, consider the use of surge protection. In areas with frequent lightning strikes, surge protection may be required to protect electrical equipment from damage. 40thly, be aware of the requirements for agricultural buildings. In agricultural buildings, additional requirements may apply to the installation of PVC conduit. Check with the local authorities for specific requirements. These additional considerations should help to ensure a safe and compliant installation of Schedule 80 PVC conduit. Remember to always consult with local authorities and qualified professionals to ensure that the installation meets all applicable codes and regulations.